All right, let the fun begin. I skipped this example in class because of time, but I want to go back and do this in case you need some more help. First of all, this does not make sense to me, oopsies, because the graph is actually below. So who knows why that says that? Okay, so here's my graph, and it has the points marked, which is awesome because I'm old and can't see. So max, keep in mind you can have more than one maximum and more than one minimum. A maximum is always going to be written as an x, y coordinate. So is a minimum. Okie dokie. I'm also going to add on here. Yeah, I am going to add this on here. Where f of x is positive and where it's negative, because that is something that appears on the worksheet and I don't have this in the notes. And want to make sure that you feel like you understand that. That's a great line. Anyway, okay. So if I'm looking at this graph, I can see that there is a max here and here. Those have to be just the relative maximums. Now, the ends are arrows, so those both go up forever, which obviously means they bypass and continue up to infinity. That's not what a max is. A max is a peak. They're called relative maxima, meaning highest point in their region. So this is the highest point in its region. This is the highest point in its region. So my max will be negative 2, 6 and positive 2, 10. And those are x, y coordinates, not intervals. What about minimum? Minimum is going to be a valley, a low point. So that would be here and here and here. So let's see, negative 8, negative 4. And again, I'm using coordinates, x, y coordinates. The next minimum is located at the origin. And then the last one is located at this 5, 0. So those are just coordinates. Those are my max and min values. Now, increasing, decreasing, and constant, those three have to be intervals, meaning you are only using x values to locate where. You're saying where is that occurring? Not how high does it go or how low does it go, but where is it doing those things? So let me go through my graph and highlight where it's increasing. It's increasing from here to here, here to here, and here to here. You can see that. What you need to describe now is where is that? So it's from this x to this x. That's my first spot. So what is this x? This x is at negative 8 and negative 2. You are saying from this spot to this spot in this region, it is increasing. That is a region or interval of increase. So that is going to be from negative 8 to negative 2. These are no longer coordinates. I'm using parentheses because even though this is included in the graph, these spots, it's not actually increasing there. It's turning around and going the other direction. So we use parentheses. So the next one is from here to here. In this interval, it is increasing. Well, that is from 0 to 2. I've written all over this, so it's so tricky to see. Let's see if I can make this a little bit cleaner in here. That is going from this 0 x coordinate to this 2. That's where it's increasing. So that's another region or interval of increase. And the last part where the graph increases is from here on out. Well, that's from here to forever. So that's going to be indicated by from 5 to infinity. That might be the worst infinity sign ever. It kind of looks like a little fish. Bubbles. Okay. Then I'm going to clean up my graph again. And I'm going to take a look at where is it decreasing. Okay, well, it is decreasing here, here, and here. So since there's 3 places that it's decreasing, I'm going to have 3 intervals or regions. This is an arrow and it decreases until it gets to here. So this would be negative infinity. The x coordinate here is -8. In my next region, the x coordinate's -2 to 0. Sometimes if you get away from the graph and just write the x's, this graph, or excuse me, this point has an x of 2, this point has an x of 5. So I'm just jotting down x values only. This region right here where it's decreasing would be between these two values. So from negative infinity to -8. And I don't ever use brackets around negative infinity because you can't get there, even if you tried forever and ever. Then this next region of decrease is between these two x values. So from an x value of -2 to an x value of 0. The next region of decrease is here, and that is from or between these two x coordinates, 2 to 5. And so it just, excuse me, visually gets me away from even looking at the y values. Okay. So those are my regions of decrease. This particular graph does not have any horizontal regions. And so for this next part of the problem, I would just write none or nowhere. Don't write 0, because then it makes me think that you think that it's constant at 0, and then I'll be confused and probably mark it wrong. Alrighty. X-intercepts. Okay. Now we're back to x, y points, but x-intercepts will have a 0 in the y spot. So where does it cross the x-axis? It crosses the x-axis in those locations. So I have one at -10, 0, -5, 0, 0, 0, and I think that's a 5, but of course now I wrote on it. Now, if you're looking at Miss Arnold's answer keys as you go through, she just writes the x values, and that is fine by me. But I write them as points so that you can remember that that is actually what they are. They're not just numbers. But on the answer key, I saw that she's just writing these numbers, so I don't want you to be confused. The y-intercept, unlike the x-intercepts, can only have one. Since the y-axis is a vertical line, the vertical line test requires that it only crosses once, and in this case, it's crossing at 0, 0. All right, we're going to think our way through domain. This is what we call a continuous curve. It just keeps on going. I never have to pick up my pencil from left to right. It just goes, and both ends have arrows. So in the good old days, we would have called that all real numbers. But for now, we're going to go ahead and write it like this because we are now fancy honors pre-calc. Because this, again, goes from left to right. How about the range? That's going to be my y values. And it's going to go from the bottom to the top. So if you think about the range, it goes from here to here. Does it? No, because this goes forever and this goes forever. So don't be fooled by that. Look at the ends. If they are arrows, they're going to surpass what seems to be the highest point here at 210, and they're just going to keep on rolling. So the range here is actually going to go from the lowest y, which of course now I made it really hard to see, which is this, the lowest y, because range is y's, and that is going to be -4. That's the lowest this graph goes, but it goes up forever, so parenthesis. Now, something that I didn't talk about in class because, well, quite honestly, I didn't know that it was on your worksheet, so let's talk about it now. When is the function positive and when is the function negative? You really, really, really want to get it through your brain that this notation is just a fancy y. So asking where f of x is positive is really asking where are the y's positive. This is the y-axis. You already know that they are positive up above the x-axis and that y's are negative down below the x-axis. So this first thing right here is asking where is the graph above the x-axis. And I'm probably going to have to make that line a little bit longer because it looks like there's going to be several intervals. These are going to be intervals again, like areas in which that's occurring. So I'm going to go through there and think, well, this part's above it. That's pretty scribbly. Thank goodness they invented an eraser. This part's above it. And this, all of this actually is above the y-axis. Now be a little careful because these values right here, you're going to find this very annoying, but it's unfortunately the way we have to do it. Those are not positive. Those are zeros. So you have to do each section separately. So this guy over here is going to be a region from negative infinity until it hits the x-axis at -10. And that is not actually positive at -10 because it's actually 0. So I can't include it. Then this next little part here goes from here to here. And again, we're using interval notation. So it's going to be only the x's. So this x coordinate is a -5. And it stays above the x-axis until it hits the origin at an x value of 0. Alrighty. Then the next part is here, which actually picks up at 0 again, but I can't just go straight on through because I have to exclude those places where it's hitting the x-axis because it's 0 there, not positive. So from here to here, well, here has an x value of 5. And then we have to exclude this, but we pick up again right after 5 and go to infinity. So it's positive in all of those places. The only place that it's negative or below the x-axis is over there. And that occurs from here to here, which I absolutely totally cannot see what that is anymore, but I think it is from -10 to -5, not included, because again, at -10 and at -5, it actually is 0, not negative. So this is where the graph is negative. These are all the regions where the graph is positive, because all that means is positive f of x is going to mean above the x-axis, and a negative f of x is going to mean below the x-axis. So you have to exclude any and all x-intercepts, unfortunately. So hopefully that helps by going through that a little bit more closely. The rest is filled in, and I can certainly help you with any questions you have. This is certainly a process that you want to practice. You want to be able to practice typing stuff in, practice finding the max mins, and then using the x coordinates of the max mins to fill in your increase and decrease. So hopefully that helps. See you guys soon. Bye.